Hi guys, Miss O'Connell here. So today we're going to be talking about vectors, which we began to talk about yesterday. We know the difference between a vector and a scalar. A vector is a quantity with units, direction, and magnitude. So today our objective is to just practice measuring the direction of vectors that have two dimensions, or meaning they have an x and a y component to their motion. So there's two different conventions in physics in which we measure angles or theta with. We'll talk about both methods and do an example. So method one, we call the counterclockwise convention. That is abbreviated as CCW. So sometimes you'll see positive CCW. What that means is that theta, the angle, is measured from the positive x-axis, or east. It's sometimes referred to as the east convention. So theta, the angle, is measured from the positive x-axis to the vector. Method two, we call the nearest axis convention. So with the nearest axis convention, the vector is between two axes or two directions. Okay, so you can measure theta from one of the two nearest possible axes to the vector. Okay, and then that is a method in which we measured the angle yesterday. So we would use north of east, east of north, okay? And we'll practice both methods of measuring theta right now in two examples. Okay, example one. Counterclockwise convention. So let's say we have an XY axis. Okay, in our fourth quadrant, we have some vector with an unknown magnitude. We know that the angle between the positive x-axis and our vector is 75 degrees. Okay, in the counterclockwise convention, we want theta, the angle between our positive x-axis, which is east, and our vector. So the theta we want to measure, we're going to start at positive x, move all the way from positive x to our vector. That is theta, the angle we want to measure. Okay, so we know that from east all the way back, from counterclockwise to east again, would basically make a circle, right? A circle is 360 degrees. So to find theta, we're going to take 360 degrees and subtract 75 degrees. So our theta here is going to be 285 degrees. Counterclockwise. Okay, so we measured our direction of our vector from the positive x-axis to our vector. We label that vector CCW, counterclockwise. Okay, let's try another example. Okay, example 2. Again, here we're going to use the counterclockwise convention. In this example, okay, we have an XY axis. That's a little messy, so I'm going to go back and do that one. An XY axis. On our XY axis, let's say in the first quadrant, we have a vector that is 25 degrees from straight east to measure theta, the direction of our vector, using counterclockwise. We're given that angle already. Theta is 25 degrees counterclockwise. Okay, so now let's take these same two vectors from example 1 and 2 and apply the nearest axis convention to describe theta. So in example 3, we again have a vector that's 75 degrees below the positive x-axis. We're going to use the nearest axis convention to label the direction of our vector. Okay, so here, right, we currently have theta. The angle from straight east towards the south is 75 degrees. So from east, you would walk 75 degrees towards the south. So one way in which we can measure theta would be 75 degrees south of east. There is another way, however, in which we can measure theta. The next nearest axis is from our vector to straight south. So another way in which we can assign direction is we could say theta is equal to 15 degrees east of south. So from south, we would walk 15 degrees towards east. So theta would be 15 degrees east of south. So despite the fact that this convention is called the nearest axis, which would imply that you need to measure theta from your vector to the nearest axis, it's really either two axes that are close to your vector. It's acceptable to measure theta from either of those axes as long as you assign direction correctly. Okay, so let's try one more, example 4, using the nearest axis convention for measuring theta. So on our xy axis, we have a vector, 25 degrees from our positive east. Two ways in which we can measure theta. So we could use 25 degrees north of east, right? You move north from straight east. Or we can choose our next closest axis, (90 minus 25). Our next closest axis would be 65 degrees east of north. Okay, so now that we've practiced two ways in which we can measure theta, what we're going to do is in Classroom there is a link to vector concept builders. Okay, so you're going to click that link, head to the vector concept builder.